Our next example is asking us similar questions to what we saw in example 6. The difference is that we're only looking at how much interest we earn here. So our answer will be not in two parts like we had here, but just that interest earned amount. Because this is essentially plugging numbers into a formula, I'll walk through identifying all those key pieces and then I'll leave the formula part to you. So if I'm going to compound quarterly, my principal is 1,000. My rate is 8%, so 0.08. We're compounding quarterly, so that means our number of compoundings in a year would be 4. And we're leaving that money there for 5 years, so our N would be 4 times 5. And again, we would be plugging this, since we know the number of compoundings in a year, we would be plugging this into our first compound interest formula. For part B, since we're compounding continuously, we're going to use that second compound interest formula. So our principal is the same, our rate is the same, and this time our time would just be 5 years. Remember, E is not a variable, E is a number. There's a key for that on your calculator, so we're not plugging in anything for E. We are just utilizing the E key on your calculator. If you've forgotten where it is from Algebra 2, it's right here in that same row with 1, 2, and 3. So I'll leave those to you to plug in. You can check your answers with the key that's on the website. Where I do want to focus is on example 8. So this is where we have a different piece of missing information. For each of these, we're looking at how much interest have I made. For A and B on number 8, we're looking at some different piece of missing information. So for number 8, part A, it says we have $1,000. So I know my principal is 1,000. I know I'm compounding quarterly. So my M is 4. That also tells me that I will be using that first compound interest formula. I know that I want to have $150. I know my interest is $150, which means that my accumulated amount would be $1,150 if I add the interest and the principal by the end of 3 years. So my N would be 3 times 4. What I don't know is the interest rate. So I'm going to plug in all the pieces that I know to solve for the part that I don't. So 1150 equals 1,000 times 1 plus r over 4 to the 3 times 4 would be 12th power. Now what I'm going to do is unravel this so I can get r by itself. So in order to get r by itself, I have to get inside this set of parentheses, which has an exponent. In order to do that, I first need to get this coefficient out of the way. So I'm going to divide both sides by 1,000, and I get 1.15 equals 1 plus r over 4 to the 12th. I have a 12th power here, the same as if I had x squared equals 16. I could undo that square with a root. We can undo this exponent with a root. This time, since we have the 12th power, we will use the 12th root. And again, you can do this on your calculator. I'm just going to leave this as the 12th root for right now. So the 12th root of 1.15 equals 1 plus r over 4. I'm going to move that 1 to the other side. So I have the 12th root of 1.15 minus 1 equals r over 4. And then I multiply both sides by 4 to get r by itself. Now keep in mind when I multiply by 4, it's this entire side over here. Again, on my calculator, that root would be this guy right here. See in blue, it says n as the index for my root. So when I type this in, I will want that root, not just the regular square root. So I'm going to type this whole thing into my calculator to solve for r. And I get r to be 0.04684. If I round, we'll round to 2 decimal places on our percent, so that would be there, 4.68% for our rate. Part B is a similar problem. The difference is that instead of looking for the rate, we're going to look for how long we need to invest our money. So this time our principal is $2,500. Our rate is 7.5, so 0.075. We're compounding monthly, so our M is 12. And I want to know how long should I leave this money there so that I can earn $1,000. So I don't know my N. I know that it's going to be 12 times something. And what I do know then is my accumulated amount, which will be 1,000 plus 2,500. So accumulated amount of 3,500. I'm going to plug in all the parts that I know. So 3,500 equals 2,500 times 1 plus 0.075 over 12 to the 12x power. Again, I don't know how many years, but I do know how many times I compound in a year, so I know my exponent should be 12x. Again, I'm going to start the same way I did before. Anything that's not part of this thing with the exponent is going to move to the other side, so I'll divide both sides by 2,500. And I get 1.4 equals 1 plus 0.075 over 12 to the 12x. This time, I don't want to use a root. I don't want to use a root because my variable is in that exponent. So if I take a root, the root I would have to take is the 12x root. So I've simply moved my problem from being an exponent to being the index for a root, and that's not helpful. What we're going to do here is call back to our logs from Algebra 2. So I'm going to rewrite this thing as a log. So I also want to note really quickly that this is 1.00625. So I'm going to use that in my next step. So I would have the log base, this thing, remember the base for the exponent becomes the base for my log. I'm taking the log of 1.4, and that equals my exponent, 12x. Last step to get x by itself is to divide this entire thing by 12. And then this whole business I can just type in my calculator. Remember, you do have a log key right here. It would be control and then the 10 to the x key to get the log. And when you type that in your calculator, that little box will pop up so you can enter the base, and then parentheses, you can enter your number. Make sure you're outside of that parenthesis before you hit divide. So you can get your x of 4.5003, or approximately 4.5 years.